Okay, do you guys see that it's recording?
I did, yeah.
Okay, awesome. And then let me share the screen. Oh, I can't see the chat anymore. One second. Zoom's a bit weird sometimes. Okay, I can see the chat now. Awesome. Can somebody type something in chat just so I can double check? Awesome, thank you. So last time we went over, just basic assembly stuff. Were there any questions left over from last time? Kind of. You're basically the person that might. Nope. Okay. Awesome. Ep, how good is your assembly? I can't see people typing anymore. This is not as much fun as last time. Okay. Stephen, you're just gonna be my talking person. All right, so today we're gonna just finish up going over assembly. We're gonna go over stack stuff a little bit, and then we're gonna dive into how opcodes and disassembly works. Does anybody here have any experience with disassembly other than Stephen? CTS stuff. What type of stuff have you done in disassembly? Kind of, have you actually disassembled on your own, or have you used the disassembler?
Oh, periodic. Like if the area that goes to negative infinity is the area that goes to positive infinity.
I don't know who that is. All right, using a disassembler. All right, awesome. All right, so today we're going to go into how that actually works on the, on a fundamental level. All right, so has anyone here worked with, stack-based assembly language, or any just stack-based, right? So earlier we were talking about registers, right? So we talked about how all these registers work, and then there's also stack-based instructions. So in x86, you're mainly going to see stack-based instructions when it's involving functions, just to save function values and all that. And what it basically does is you have your push and your pop. Push pushes the value onto a stack, and then pop gets the value off the stack later. So it's basically just like putting it there, and then you take it back later. There are some languages, such as like Python, where it's completely stack-based rather than registers at all. And after we go over the opcodes a bit, you'll see why some people prefer to do stack over registers. But are there any questions for that part? No? Okay, I'm gonna assume that there's no questions. Hey, all right, so we have a few more people joining us. Hey, Seal.
Oh, wait.
All right, so now we're gonna start off with the actual opcodes, how all of that works. So have any of you ever actually worked with opcodes before? Also, if you can, have you've worked with opcodes, Stephen? Like actual bytes for controlling things.
I was writing my own disassembler a little bit. So.
Yeah. All right. Also, for those who joined, I really like when people unmute and talk and respond to questions. So if you can't, you can just type. That works too. All right. So we have opcodes, which are basically 1 byte each. And then after each opcode, it tells you what it's supposed to do. And then there's, sometimes there's no instructions after, but most of the time you have between 1 to 4 bytes afterwards, which are operands. What those operands basically do is they tell you what registers, what values, stuff like that, right? So then most actual instructions like move, add, all of those have a lot of different opcodes just because of configurations. And then there are a few opcodes that also represent several different ones, such as the B1 opcode can represent all of these instructions. And just to give you a quick view, for x86, this is basically the opcode table. So you can see, you have your opcode here, right? And then tells you what it is, registers that are used, all of that. And we'll go over how to read this table in a bit and how to actually understand it. But there's a lot, right? And then there's also two byte opcodes as well. Who just joined? Hey, Rondo. All right. So for those who joined, I sent a link in Drive as well, where if you want to follow along, you have this PDF, and then you also have this file that we're going to be working through later. Okay. So now that we've kind of discussed, how the opcodes and all of that works a little bit, is a lot of times you'll see here, you have this little R value afterwards, and then you'll see here you have, either R1632, you have RM1632, or R8, RM8. Can anybody guess what the numbers after mean? So, what does the 8 mean? What does the 16 mean? Cams, what do you think those mean? Size register? Yeah. Okay. Yeah, exactly. So, you either have a byte or you have a word. And then you also have this, but yeah, it's the size. So how are you going to get two registers, two different registers, if you only have one register byte, right? Because you have the opcode byte and then you have a byte for the register. So that's one of the issues that, comes here, because we want to use as few bytes as possible. So does anybody have any guesses on how we would, use one byte to encode several different values? Hey, Bex.
Hey.
Bex, what do you think? How do we encode two different values in one byte? Any guesses? Do you have experience with dealing with opcodes and manually disassembling?
No, not
Okay.
really.
All right. So do you know what opcodes are?
Yes.
Okay, perfect. So, we have all these opcodes. So, if we have 0, and then we have one other byte, but then we know that it's add because of the 0, 0. And then we know from this byte, we have to read these values. So the way that this works is you have your RM and you have your R. So if you look here, this is normally how the mod read, the RM byte looks. So this R byte afterwards, you have the first 2 bits are going to be your mod value. The next 3 bits are going to be your register value. And then the last 3 are going to be your RM value. And the way that it works is, let's say we have this table here, right? So we know the size, right? We know the size of this instruction because it's 8. And that's just because of the opcode. So you see here we have add of size 8, and then we have add of size 16. So here we only have a byte, and here we have a word, or D-word. But the way it works is we know that we need to get the RM value, and then we need to get the R value. So for the R value, we have 5, 4, 3. Let me pull up an example real quick. Zoom is covering that. So let's say we have 9, 7, right? Hex value of 9, 7. Zoom. That's in the way. Can you guys see the Zoom bar, by the way? I don't think you can.
No.
No.
So let's say that we have 9, 7 as our value, right? So these are our bits. So what are the mod bits? What are the register bits? And what are the RM bits? If somebody could answer that. Steven, what are the mod bits?
Mod bits are the first 2, so 1, 0.
All right, and what's that value?
That would be 2.
All right. Let's see, Khan, what are the register bits? Yeah, the nice thing about Discord is you could see if somebody was typing or not. Yep, exactly. And then let's see, what are the last 3 bits?
Which
What do
number?
those represent? Just what do they represent? And what's the number?
The and it's should be 7.
So, yeah. So we had RM and then R, right? So the first thing that we look up is going to be our RM. And the second one's going to be our R. So if you had this instruction with that value, it'd be 0097, and then you'd get add, and then you'd get the RM, comma R, right? So now we have to figure out what this RM is and what the R is. All right, so we have, these lovely tables here. I'm trying to move the zoom thing around. So the way that works is RM, it gets modified with the mod values, and register you can straight up look up. So this is going to be for your register value. So we had 010 for our register value. So which of these values is it going to be here? Can anyone guess? And keep in mind the size is a byte. Okay. So based on 010 and a size of R, so it's 8, right? The R8, which of these values is it going to be? Stephen.
That would be DL.
DL, exactly. Does everyone see why? Because R8, so we're going to look at this column, right? And then we have 0, 1, 2. So we know that DL is going to be our first value. Does that make sense to everyone?
I've had a question of where'd you get the 97 from?
Oh, the 97 is in our exercise later. So I just pulled it up now already, just so we could show. But like, if this is our opcode and instruction, this is going to be our output. Does that make sense, Stephen? I'm just pulling a number to show. Okay. And then I'm actually going to modify this because this one might be a bit difficult right now. So we're going to say that our mod value is 11. So we looked up our register value here. Does anybody have any guesses how we're going to look up our mod value? Our mod and then our RM value. This is RM. This is DL. Sorry. Bex, what do you think? Do we use this, or this with this mod value?
I have no idea.
So here we see mod here, right? On the table.
Yeah. So yeah. Okay.
So we use this last one,
Yeah.
right? And then what value do we use to look up which one it is here? Do we use this one or this one?
The middle one.
The middle one? This is our RM. We're looking for the RM value. Because the
Okay.
register, we can look up, the RM has to come from mod. All right, so which one? So we use this one, right?
The 111. Yeah.
All right, so which one of these is it going to be? Or which column or row do you think at least?
The last.
Okay, and then what was the size of the instruction? It was RM8, right?
So 1 byte.
Yeah. So which of these is 1 byte?
The first.
Yep. BH is 1 byte. So as you can see here, this is how it all breaks down. So we know that's the one we want, right? Now, the reason that we use the RM, or I guess we'll do another, just a quick exercise real quick, just to see, give you guys a bit more practice. So let's go, random values. So what is going to be our register value for this one? Con, what's our register value? And we're going to assume it's 8 bits, so 1 byte. Did you type already? Was that you just, did you just now type that, Con? Sorry. The DL? Okay. No, it's not DL. Bex, what do you think it is?
I would say DL2, so I don't know it.
this is our new register value, right? Here, register. So the first value we want is the register value. So using this table here, what is our register value?
BL.
Yes, BL. Conv, does that make sense? Because registers these middle ones, so we look it up here. All right. So now
So
let's see. Oh, go ahead.
For what was the mod value? The 1 1.
Yeah. So this, yeah. What's going to be our RM value? Okay, sounds good. Con, what do you think our RM value is going to be? And Bex, you can answer as well. I can't tell if Com's is typing or not. What's our RM value?
Das.
First, what's the
So-
first thing that we check for the mod RM value? 5? No. All right. So what's the first thing that we want to look at, right? We want to look at the mod value first. So what's our mod value?
11. So the last.
The last row.
Yes, in this field. Yeah.
All right.
And then in the. I don't know how it's called in English. In der nächsten Spalte.
Yeah. So this row, right? Or these rows. And then, all right, so we use the the mod value to look up which basically set of rows it is. And then Con, you are right. So the RM value is 5. So then which of these are we using for the RM value?
The third last. So CH.
Yep.
I would
We
say.
use that because it's, this RM value and our size is going to be a byte. Does that make sense, Con? Okay, awesome. So now you're probably wondering, why do they do this like this, right? And what are all these other mod values for? So in our exercise last time, you remember we had that, lesson.asm where it basically let you, look up values and then it converted it to hex. And then, at some point we had to do something like codes, which was, part of that was in the data segment. Codes is in the data segment plus bx, right? So, and we moved that to DL, I think. Right. So we don't, that's going to be kind of hard to encode if you don't use the mod RM value. The reason for that is because, so now let's go back to the 9-7 example. So Con, what is our mod, or what is our register value for this? Okay, so if it's 2, which register are we using? DL, exactly. All right. And now, Bex, what is our mod RM value?
And BX plus this 16.
Yep. All right. So remember, so we just had this part. So now we have BX plus, whatever is going to be displayed later. So the way that works then is that you're going to look up another value. So it's going to be, whatever the instruction is. So like opcode, then we have 9-7, and then we're going to have two bytes because we have to look up that value, right? To find the offset to where that is stored. Does that make sense?
Mm-hmm.
Right. Any questions here? No questions? All right. So this is for 16-bit, but there's also going to be 32-bit. Works in the same way, you just have different values. You're not going to have to focus on this one right now. As long as you understand the general of how it works, you're good for any language. And that's what our crash course is trying to do. You're not supposed to be able to code entire programs in assembly. You just have to be able to read assembly. You don't have to know how all the opcodes work, from the top of your head, but you'll be able to look them up, right? Okay, so now we are going to go through and we are going to actually do some hands-on examples. So we have this table, which I'm going to send here, and we have, we had that table, and we have this table, right? Okay. If any of you want to follow along, the drive I sent had this folder in it, and this folder basically has like a quick disassembler that I threw together, as well as some blanks that you guys are going to have to fill out. Lovely. Okay, so we're going to walk through right now, just real quick. And so from the lesson plan last time, we had made an executable, right? A binary or an assembly executable. And these are all the opcodes that we use in there. So the first few we're just going to walk through. We're going to do it by hand. Then I'm going to show you how the program works, and then I'm going to have you actually add to the program to implement parts that aren't there. All right. So the first value, I'm going to copy this into here so I can have the other screen open. All right. So what's the first thing that we're going to do on this table, given those opcodes? Steven, what's the first thing we're going to?
We're gonna look for where BB is on that table for the opcode.
Beautiful. Does that make sense to everyone? Because that's our opcode. First instruction is the opcode, right? So we go down to here. Oh no, where's BB, right? So this is a tricky one, okay? I know, horrible to start off with. But any guesses here on how this works? So BB is going to be greater than B8 and it's less than C0. So what instruction are we using here? Any guesses? Or is it just not an instruction? Yeah. All right. So Cons, what do you think that plus R means? All right. So it's part of the actual assembly here, or the opcode, right? We don't have another register value. There's not another value there. So as I was saying before, when they were writing this, they cared a lot about saving every single byte possible. Stephen and I were working on something earlier today where it was painfully obvious how much they were trying to save bytes. Right, Stephen? Just the one byte would have saved all that trouble. So does anybody notice what's the difference between B8 and B0? How many values is that? What's B8 minus B0, anyone? Eight. Okay. And what do we have 8 of? Bex, what do we have 8 of? Registers. Perfect. All right. So any guesses on how this might work? If we have BB as our opcode and then B8 plus R as an acceptable operation. 1 second. While you guys are figuring that out, I'm going to see what the dog needs. All right, Stephen, what is it? What's that difference tell us?
Since BB is 4 greater than B8, wait, no, that might not be right. Hold on, I didn't actually do that math. It's whatever difference that is greater than B8.
Yeah.
And
So we
so
have,
you would
you
probably
know,
look up what R is on that table we were just looking at.
exactly. So, you know, B9, BA, BB. Exactly. But that is how that works. So we would have BX, right? Because we know that it's of size 16. So that it's a D word, right? Does that make sense to everyone, that part? How we know the size based on the operand? Yeah, okay. So we know that our first value, our R, is going to be BX because we did BB minus B8, and then that value was this value. Now, what's the second value going to be? Does anybody have any guesses what IMM stands for? Bex, what's IMM
Nope.
stand for? All right.
Not sure.
Or I guess English is not your first language, so that's a bit mean. Steven, what's IMM stand for maybe?
Immediate value.
Yeah, so immediate memory, immediate value. Okay. So what size is this, Bex? Is this a byte or a word or D word?
D word, I would
Okay.
say.
So that's going to be 1 or 2 bytes.
2.
2. All right. So does everyone see how we have the 0, 0 as the next 2 values? So that's how we get the, I cannot pull that over. Okay. The Zoom windows are just in the way. Sorry, guys. 1 second.
I thought our D word was 4 bytes, by the way.
This
was 2.
D word should be, I might be using the wrong terminology, but
It'd be like byte is 1 and then word is 2, I think, and then D word is 4.
I think, yeah, that might be it. Maybe wrong terminology, but you guys get the point there. So we have move, right? Because we hit the, you know, it's between the B8 and B0, or B8 and C0. We get the BX because we did BB minus B8, and then that was 3. And then we get the 0, 0 because we have, you know, the 2 values here. Does that make sense to everyone? All right.
How do we know it was 16-bit instead of 32-bit again? I think I missed that part.
So we know because of the operating system of the machine, right?
Oh, right.
So we were doing this, yeah, we were doing this with DOS, right? So that's why it is. That's a very good question, though. That's why, you know, it could be 16 or 32. We know that it's 16 just because we know that the file or all of these came from 16-bit operating system, which is what we're going to start to discuss next time. We're going to start to discuss how file, or, you know, like the actual file types work and how the structure of files work as well. So we'll really dive into those. We'll take apart MS-DOS files, and then we'll also take apart PE files next time. So that'll be fun, I think. All right, so then this next value, where do we go first? What's the first thing that we look up? Conv.
So before the opcode.
All right, and that is here. So which register are we? All right, so yeah, which register are we using conv? So it's 4 minus 0, and then it's R8. All right, so then which one? Which one of these? Bex, which one of these are we using?
I would say 8. The first one.
Yep,
Yeah,
and it's because we had the R8. And then our immediate value is going to be 2 because that's the next opcode, right? right, so now let's change that a little bit. All right, so now I'm going to give you guys one that we haven't gone over yet, and I'll let you try it out. So what is stupid window? What is this next opcode? And just try to figure it out on your own real quick. We'll see how well you guys do. And I'll just give you guys 2 more minutes and we can just see how that goes. I think I just lost my chat window. There we go. I was on mute. Hey, did any of you guys finish or are you guys still working? Take it as still working then. Still working, okay. Or is that a thumbs up you finished, Stephen?
That's a thumb up. I have my answer.
Okay. Conf, do you have your answer? Bex, do you have your answer?
Yeah, I think yes.
All right. Everyone, Conf, you can type in chat. Or I guess everyone just type in chat what they think their answer is. That way no one's talking over each other. Okay. AX1 and AX1. All right. So Stephen and Ben were right. Conf, let's walk through and see if we can figure out what you were a bit confused about. All right. So we had B8. So what was the first thing that you went to? I mean, it looks like you got that part right. So you went to here, right?
Yep.
All right. And then you have B8 minus B8, which is 0, right? Okay. So then you look it up here. You know that you got the size right, so that was very good. You saw that it was, you know, the 16-bit. So you went to here, and that's how you got AX. So you were off by 1. I think you missed your counting a little bit. Because remember, for this one, no, it doesn't look right. So you took the 0, 1 as being the next, as being the register, right? But remember that for the B8, yeah, it's built in, right? So remember earlier we had like the BB and it was built in. Yeah. So that's how you got a little bit messed up there. So that's how you would have gotten the AX then, and then the 0, 1 would have come from, you know, the 2 operands. Okay. So let's go through
Worth
one
pointing
more.
out the Indianness there when you're dealing with that.
Yeah. That's a
It's
good point
backwards
too.
from what it should be.
It's 1, not 100 or 100, which would be 512. Yeah, 100 hex is 512. So we'll go through one more. I think, let me check. I just want to make sure I'm not too mean for this one. No, it's a bit mean to do on your own. The 00 is just an extra, byte, because the immediate value is going to be 2 bytes. So that's why you have the 0100. All right. So let's try this one. Yeah. So make sure that you have your endianness right, because otherwise you could easily say, some other thing. So it could be like 0x0100, which is very bad because that's 512, not 1. Right. All right. So I'm going to give you guys one more of this type to go through, and then we can carry on from there. All right. So I'll give you guys 2 minutes to do this, or not 2 minutes, 1 minute to do this one. Should be good. All right. And everyone can just send their answers when they get it then. All right. Awesome. All right. So everyone was good there. That's good. All right. So that's, how that one works. That one is a bit weird. So that's why I wanted to enforce that one. There's another one that's a bit weird, which we're going to go over now. So I was saying how with most of them, you have several instructions, or, like one instruction is encoded across several opcodes, right? But then how there are sometimes one opcode that represents several different instructions. D1 is one of these, D0 and D1, right? So based on this, how many values can we expect to need? X. Are we going to use one opcode to get this value and the opcode, or are we going to use or have our opcode and then have another value?
I would say opcode and another value.
Okay, yes. So we also know that this is RM, right? Now, this one is done a bit different. So let's see. I'm trying to move everything around. So annoying. Okay. All right. So we have an RM value here, and we have 0 through whatever, right? And then here are the opcodes that we're going to try to decode, basically. Any guesses on what value we use to look up this column? Oh, we'll go over it. So D1 we know is our opcode, so we don't have to worry about that, right? So now we have EB. We have this. All right, so let's split EB up into all our different things. So we have the mod value, we have our actual value, and then we have the RM value, right? So what do you guys think we look up here in this table? So we're going to need to look up in this table something, and then we're also going to have to look up in this table something, right? Does that make sense, everyone? Yeah, okay.
I would guess you maybe use the RM portion for determining which instruction it is.
The RM?
Yeah.
Okay. So the RM you said, let me just double check that I good here because I do not want to give you guys the wrong answer. So you think we use the RM value here to figure out which one it is what you're saying?
That's my guess, yeah.
Okay. So which one would it be then based on this?
Isn't
Or the
the
RM?
middle reg? Yeah,
Yeah,
okay. So
based
that'd
on the
be 3.
RM. Sorry. So you think it's 3, which would be which one?
RCR.
Okay. And then, so you said, and then what would our register be here? What register do we, or I guess actually, yeah,
what
what
was the
register do we
size?
shift?
It's R16 and
Yeah.
it's 101. So that would be the BP.
You think BP? Okay. I'm very sorry to disappoint, but you are sadly wrong. So we're going to use this handly. So sadly, it does not work that way. It actually uses the register value to look up which one of these it is, right? So our register value is 5. So that means it's going to be SHR. And the reason it does that is because we actually need the RM value to figure out the register, right? That we're going to be moving into. Because if we use the RM value for both, then you'd be kind of limited on what you could do. Does that make sense, Stephen?
I guess so, because the RM is for like the destination.
Exactly.
Reg is the source.
Yeah. So reg, we're not using for anything here. So that's just, wasted space. We're not doing anything with it. But the RM we're actually using to figure out the destination of this operation, right? So that's why we have to use that one. Okay. So does that make sense to everyone, how that works? Ben, Conv? All right, thumbs up. Ben, does that make sense to you?
I think yes.
All right. So now, obviously, no one wants to do this by hand, right? Ever. It's awful. It's slow. It takes forever. Most of those files have hundreds, or thousands of instructions. Not something one want to do by hand. So that's why you make disassemblers, decompiler or disassemblers and then decompilers. So here I made this little program, and most of the instructions are here. So as you can see here, we get the middle 3 bits, and then we shift it left 3, and that's how we get the R value. And then we get the RM, and like the value there. And then you guys should have this available as well to you. So I built in everything here. This is one second. I don't think this is the file I sent you guys, because the file I sent you guys, I think, was missing that one value. How to do the R. Let me just double check that real quick. Does anybody have that downloaded? The one I sent earlier? Steven, maybe? Sorry. Lesson sometimes.
I don't actually know where you sent anything.
I sent it in the chat. So I sent this, CBP value for CBP. So let's
In the
take a
Zoom
look.
chat?
Yeah, at the start of the Zoom
I don't
chat.
see anything in the Zoom chat.
Oh, you guys did not get it. Okay, here. So this has this file. So yeah, I did not include this D1 in here. So I was actually planning on having you guys code that. All right, so you have, this program where it does a few things. If we run it through, so like we can test it a little bit. So, this was the value that we just tried. So if we ran that, we got, SHR BX1, right? We can try a different value. Let's try moving in, or this sub, right? And I modified this so that you guys could just copy and paste the different instructions in and kind of mess around with it a little bit. So you're just going to do G++ and then like lesson.cpp, and you can just name it whatever you want. So you see here we have the sub HAL. So one of the things that I want you guys to try to do is remember how we talked, or this one has the answers, so let me not show that one. How the mod, if the mod is 2, we do something a bit differently. Everyone remember that? We had the, we display it instead. Everyone, yeah? Thumbs up. Yep, okay. So what I'd like you guys to try to do is I'd like you guys to try to write it so that this value can be read in. So give that a try with like this decompiler code. All of you guys have Linux available quickly or not really? Sorry, I should have probably said to have a VM ready. You do? Because I don't think Clang compiles it correctly. Just because I do some stuff with pointers that I really should not be doing. All right, so I'll give you guys a few minutes to try that out. See if you can write, it's going to be right here as well. So you're going to be adding it to here based on this table and how, that works, or basically based on this table, write it so that it outputs the correct value. All right, and I'll give you 4 minutes to do that just to try it. If you can't, we'll go over the code. So no worries there. How's everyone doing? Are you guys making progress? Anyone stuck? I'll take that as progress.
It takes a bit of time just to figure out what the heck's going on in the whole C program you gave us. So.
Yeah, sorry. We'll give it 1 more minute and then we'll go over it. All right, was anybody able to get it working? Probably not, but anyone? Nope, Steven?
I have some code that may or may not work.
Bex, were you able to get it working?
Nope.
All right, so first, I guess we'll go over the concept. What's different with second case rather than the first case? What's the difference between this one and this one? Anyone? Steven.
There's another 2 bytes you have to read out
Exactly.
the instruction.
Right. So there's extra that we have to read. We can't just operate on what we have, right? So the code that we have, we increased the instruction pointer because we'd already read in the mod and the RM. That way we have the next byte. We're going to add the mod 2, right? Because we have this table here. So we have, dx plus si, dx plus di, etc. So, down here, right? And then we're going to add these 2 bytes, the next 2 bytes together correctly. And then, hey, you're pretty close.
Close to what I had.
Yeah, you missed adding this.
Yeah.
Nice. Very nice. All right. So that's just a quick rundown basically of how how you read this very ugly thing. Does everyone feel confident about, with time, if you were given opcodes and bytes, if you could figure out what instruction it is? Or should I ask, does anybody feel like they wouldn't be able to do that? And is there anything I could do to help that question real quick? You think yes? Conf, do you think you could do it too? All right, awesome. So that was our quick and dirty disassembly introduction. So, last time we did assembly, this time we did disassembly. Everyone liked the speed that we're moving at. I know it's a bit fast, but there are a lot of topics, sadly, that we were trying to cover. And the topics are going to start getting more fun too, because now you guys have almost all the deep understanding that you need. Give you homework? Yeah. So I have that uploaded. I have currently a private repo that I have, but I think I'm going to make it public, and I'm going to add exercises to it. It's this one. So you have, like the introduction to the course. Here you have, all the chapter stuff, the exercises from last time. I'm adding in, this code so you can give it a try. I'll add instructions for how to get DOS set up on your system, like DOSBox. So you can actually write your own assembly, assemble it, try to disassemble it, I'll try to get that up by tomorrow, most likely. So you will be able to practice that a bit. Next class, we're going to be going over file structures because I don't think that's going to take a full hour, because it really doesn't take that long. It's figuring out, how a file is structured, the headers, all that stuff. And then we're going to be switching more towards operating systems. Does anyone here have experience with operating systems? A little bit at least? Maybe not too much. No. We'll be starting it mostly about using DOSBox, just because it's tiny and old and easy to get running on everyone's systems. So DOSBox is what we use to assemble the examples as well. Also, do you guys recognize some of those instructions that we had today? It was from this file that we had actually assembled last class. So you guys can mess around with this. Bex, I wrote this little skeleton program so you can learn assembly. So you can, do whatever assembly you want here, and then you store the value in AX, and it prints out AX really nicely for you afterwards, if you haven't done much assembly. And then, So we'll be going over, how interrupts work, all of that, / the actual communication with the operating system. And then after that, our fundamentals will basically be complete, and we'll switch over to starting a little bit more with decompilation, actually using tools rather than writing the tools / how they work. And then from there, we'll go into all our topics, language specific things, malware, game hacking, all of that. So that'll be a lot more fun. But the issue, so many people, just use the tools. Like as Khan was saying, he used Ghidra for Pico, right? But a lot of people don't really understand how they work in the back end. And a lot of times those tools can mess up, especially on harder challenges. So if you actually know how it works in the back end, you're unstoppable, reverse engineering. Yeah, so hopefully we'll get to the fun stuff soon. I'll be sending out the form just of like feedback, what you liked about the lesson, what you think could have been improved a little bit, stuff like that. Any questions before we head out for the night? All right, I think we're good then. Thanks a lot for coming. Let me try to turn off this recording now. I guess pause share and stop share. I hope you guys all learned. It's always nice to teach